Welcome to the third installment of the summer assignment videos. And in this video, we're going to look at the third page of the summer assignment, starting with 15 to 17. In these problems, we want to show algebraically if the functions are even or odd. So in order to do that, we need to remember a few things about even and odd functions. First off, even functions. Well, how do even functions behave? Well, an even function, if we look at it graphically, is going to be symmetrical about the y-axis. And so how does that translate algebraically? Well, that means that f of negative x is going to equal f of x. Okay, so that means if you put in a negative 1 into the function, you should get the same thing as if you put in a positive 1. And same with putting in negative 2 and positive 2. They should be the same. That's the symmetry about the y-axis. Odd functions, well, they're symmetrical as well, but they're not about the y-axis or the x. They are about the origin. All right, so what that means is that f of negative x is equal to a negative f of x. So when you put a negative 1 into the function, it's the opposite of when you put in a 1. And so use those two rules. Go ahead and just use negative 1 and 1. Plug both of those into each of the functions in 15 to 17 and see, is it even, is it odd? And if it doesn't fit either of these conditions, then it's neither. Now let's take a look at number 18. And we want to find the difference quotient of the function below. So we're using this little piece here, the f of x plus h minus f of x all divided by h. And so if we have our function of a negative 2x plus 8, and we want to find, well, what is f of x plus h? So what that means is f of x plus h is putting in the quantity x plus h where we see the x. So it's negative 2 times the quantity x plus h plus 8. So if we use these two expressions to plug into our difference quotient here, and if we distribute that negative 2, we end up getting a negative 2x minus 2h plus 8 minus the quantity of f of x, and so when we subtract that, that becomes plus 2x and minus 8 all over h. And if we look, a few things cancel out here, the negative 2x, positive 8, negative 8, and we just get a negative 2h over h, and this just becomes a negative 2. And so that difference quotient, using that function, simplifies just down to a negative 2. Now, when you do 19, be careful. You are squaring x, so make sure when you put in x plus h, that quantity is squared. Actually expand that binomial. It's not just x squared plus h squared. If you have to FOIL, go ahead, but you must expand. Let's look at numbers 20 and 21. In these, we want to find the inverse of the function. And so if you don't remember how to find the inverse, what you want to do is you want to write the function as y in terms of x instead of just f of x. So you'll want to write y equals 7x minus 2. All right, now we want to find the inverse of that function. We switch the x and the y, and we write it as x equals 7y minus 2. And in order to find the inverse, we just solve for y. And when you solve for y, that'll give you the inverse of the original function. So do that for both of those. 21's a little different. It's a rational function, so you'll have to know how to solve the rational function. Multiply by the denominator, distribute, get all the like terms on the same side. Okay, and find the inverse of both of those functions. In numbers 22 and 23, and actually 24 as well, we want to find the vertex of a parabola or a quadratic when we use completing the square. So some of you may be thinking, what is completing the square again? So let's talk about that. First off, before we do that, in order to find the vertex, we need to remember vertex form of a quadratic, and that is y equals a times the quantity x minus h squared plus k, where hk is the vertex. So that's what we're looking for. We're looking to get our quadratic in that form so that we can pull out what is h, what is k, and that gives us our vertex. So let's look at our function. We have f of x equals x squared plus 2x, and I'm going to write the minus 2 over here. Okay, leave a little space, because this is where completing the square comes into play. Alright, now, if I want to complete this square, I want to turn this into a perfect square trinomial. And so in order to do that, I need to take our linear term, the b term, and I want to cut that in half. So half of 2 is 1, and then I want to square that. And so when I square 1, I get 1. And that's the number I'm going to add in here, plus 1. But the thing is I don't want to change the value of my function. And so if I add 1, I also need to subtract 1. Okay? So you might think, okay, I've done nothing, which is good. I don't want to do anything to change it, but I'm just rewriting it so I can make this a little neater for me. Okay, so I'm going to just look at these three terms, kind of block these two out of my mind. Just ignore those. We'll get to those later. Okay, if I look at these first three terms, that factors into a perfect square of just x plus 1 quantity squared. And then if I look out here, I've got this additional minus 1 minus 2, so that's a minus 3. So now my function f of x is written in vertex form. Look at that. So if it's in vertex form, I just have to pick out what's h. Well, h is a negative 1. What's k? It's a negative 3. And that is my vertex. Okay, now you might ask, why is it negative 1? Because we have x plus 1, and the formula is x minus h. So we want the opposite of what's in there. So negative 1, negative 3 is the vertex. You're going to do the same thing for 23, although you may want to get rid of that coefficient of 3. Factor that out first. It might make it a little easier for you. And 24 is a word problem, but don't get too antsy about it. You're going to end up doing the same thing with finding the vertex.